All right, well, welcome to this, our second official edition of Physics Fridays. I am your host, Eli Hibbett, and I've actually been having a little bit of a tough time with recording this thing because the winter days are so short now that I have been driving mostly in the dark. So I actually had an opportunity to leave a little early, and I was like, hey, well, let's do a daytime one. So today's episode is called Simulation Theory. And if you haven't heard about simulation theory, man, holy moly. I was reading about this I was reading about simulation theory a couple of days ago. Well, not a couple of days ago. It was actually a couple of months ago. I was talking to somebody at a wedding, and they were telling me about simulation theory and how it's related to, it's not related to anything. What is simulation theory? They have, this dude has this theory, I guess you'd say, that we are all living in a simulation. And he's got some pretty interesting evidence, I would have to say. It's pretty compelling. So what is the idea? So first of all, we currently have the ability to make simulations, no problem. And even since the 80s, the ability to make simulated environments has been getting better and better and better. And if you've played a video game, you know that that is definitely the case. And if you're a scientist who's done any sort of simulation research, which I did in grad school, it's getting a lot better. I mean, the technology is really there. The processor power is getting better all the time. And if you take this out, you assume that we're going to be getting better and better all the time. So there will be a certain point where we will be able to simulate our entire universe, or some part of it. And we're also kind of destroying our ecosystem. But if you want to simulate, how civilizations acted at certain points in history, it wouldn't be too terribly difficult to run a simulation. It wouldn't be too terribly difficult to run a simulation of it. And so you can actually watch how a society evolves by making a simulation, which is really, really cool. But there's also kind of this, if they're actually, sentient beings... This thing, man. So if there are actually sentient beings inside this simulation, what is the code of conduct in terms of shutting it off or killing people inside of a simulation? So that's one question. But we could just be experiencing a simulated version of reality. So what could we do inside of our simulation? Let's just assume for a second that it's true and we are living in a simulation. How would we know? How could we tell? Well, one big thing is that, you ever see The Truman Show? You know how he sails out and he crashes into the edge of the set? That would be one thing. Is that there's a boundary, and we have a boundary in our universe, if you can believe it. So if you have a boundary, there's a certain resolution that your simulator computer can do, and so you can't have everything, and so there has to be this boundary on the big side, which we definitely have. Check. Number 2, boundary on the small side. We are not continuous parts. Oh, we're not just a continuous thing. We are made up of small pieces that are made up of small pieces all the way down. And we found out that there is a limit. And this is the uncertainty principle. You cannot know the momentum and position of something at the same time. There's a limit to how well you can understand with any certainty the position and momentum of something. So that is on the other side, which you could theorize is due to processing power. This is the best that this computer can do. And so check, number 2. The other thing that's wildly compelling about this is in a simulation, like for us, like they're simulating. Let's be so egocentric as to assume that they're simulating humans, right? Everything in our level of being is in check. You throw a ball, it goes up, it comes down, X, Y, and Z. All that stuff works. But as we have gotten creative and we've started looking at very big things on the macroscopic scale and very small things on the microscopic scale, we've learned that the laws behave differently. And right now, classical mechanics, general relativity, large-scale things do not mix, do not jibe with small-scale things. Quantum mechanics. And it's not like, well, hey, you know, if you just look at big things and you just look at small things, it's fine. There is some point where they have got to line up. There's got to be, like, even if you say, okay, at, you know, 1 micrometer, quantum mechanics takes over and classical mechanics fails. But there is not that thing. That does not exist. And so macroscopic and microscopic rules not lining up is another telltale sign that you are living in a simulation. And probably that the person that did the programming didn't do a very good job, I would have to say. But it's also kind of interesting to me because it would explain, I mean, like, the person that started the simulation is God, right? Like, he is the beginning and the end from the Bible. He is the starter of the Big Bang, whatever you want to call it. And he's controlling all the people. He's got all the cards. You know what I mean? And so, wouldn't that be something if that was what everything is? Turtles all the way down, you know? But, so I am, like, fascinated with this idea. And I also had this other notion of kind of where I wanted to go with Physics Fridays. And I was like, wouldn't it be cool to kind of do a post-mortem on every chapter of the Elegant Universe? I have not finished the Elegant Universe. I've been trying to read it since I was in high school. And I've gotten pretty far into it, but I've always been derailed. It's not like I'm not interested, but life just gets in the way. And so I've made it about 3/4 of the way through it. So I was like, I'll read the whole darn book, and then I will take about 10 minutes a week and pontificate on each chapter. And I thought that was a pretty slick idea. So I think next week I'm going to start with chapter 1 of Elegant Universe. So I dug out my old Elegant Universe book, and I started checking it out. And the first thing that he says is that, you know, string theory is the solution to uniting macroscopic classical mechanics and microscopic quantum mechanics. And that right now, they both can't be right. But apparently, if string theory is correct, this is the big unity. So for me, you know, being obsessed with this whole simulation theory thing, string theory is the key. Now, it's not like, you know, nail in the coffin kind of key, but if string theory is right, then the grand unified theory, you know, wahoo, we're not living in a simulation, great. And if string theory is not real, it definitely raises some questions about whether or not we're living in a simulation, because if we can't prove it, if we can't lock it down, who knows what's going on. So think about that when you're laying in bed at night, you know. They also, I mean, the idea that you have to go to sleep and that, you know, you kind of shut off every 8 hours and you start getting tired and, you know, you start, not hallucinating, I'm never like hallucinating because I'm tired, but like things stop making sense, and, you know, you can start drawing all kinds of, you know, unsubstantiated parallels to fit in with simulation theory, but it's kind of hard to refute, you know. I'm not saying we live in a simulation, but it's kind of fun to think about. And when you start looking for clues, it's not that hard to create a compelling argument. Not an airtight argument, but a compelling argument. And so right now I am compelled. And I thought I would try to compel you today. So, and the other thing, I was looking at XKCD. I don't know if you read XKCD, but he made a joke on the latest comic about angular momentum and exposition. So I will include a link to that comic on the blog, pwnyouRHW.blogspot.com, if you're into that kind of geeky humor. And other than that, yeah, this is the big question. Are we living in a simulation? How interesting is that, man? There's a cool TED Talk about it. I mean, there's all kinds of literature about it if you're into that sort of thing. Check it out. And next week, I'm going to be coming at you with a little bit of Elegant Universe. So, dig it, guys. Until then, I'm Eli Hibbett. Have a great day. One more thing. So, another compelling reason, if we're living in a simulation, then the fact that we have physical laws makes an incredible amount of sense. Because you're just coding into a computer. I mean, how great would that be? You know? No? Am I crazy?